There you see error image pull, and the next status would be image pull back off. Perfect. Now we should see this. Let's say there is a developer finding it difficult to understand what went wrong with the cluster or what went wrong with the pod. They can come here, click on it, and click on investigate the cluster. If they have access to the cluster right now, this is using my kubeconfig file, so I have access to it. What is it doing? It is investigating, checking the pods, reading the logs, analyzing the events, inspecting the deployments, checking the networking, giving this entire information to AI. Basically, we are using Open Router here and root cause found. You can see it performed the root cause. What does it say? The pod Nginx image pull backoff is in pending state due to an image pull error on non-existing image tag. It exactly explained you the issue. This is the image that you're using, and this image is invalid image. Just use the valid image, something like Nginx latest. It also gave the kubectl command. This is the confidence score. AI is confident that the command is 80% correct, or the investigation is 80% correct. There is a reason for it. Why is it not 100%? Because there is a possibility you might not want to use this image. Maybe your organization wants to use a different image. And it also says, how do you prevent these issues in the future? Probably use the CI/CD checks. On top of that, we also have the recent investigations. Till now, we did 3 different investigations, and all of the information is stored here. Where are we getting this from? We are getting this from the InfoJ database that we configured. And this is also automatically configured. We have investigations table and we have investigation progress. All the previous investigations progress is here, the different steps that were performed. And these are the different investigations. First issue was because of core DNS. Second issue was because of Nginx crash, the crash loop backoff. And the recent one is because of Nginx image pull backoff. The same information is shown here. Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's build an AI Kubernetes agent. We will do this in 5 simple steps. Step 1, problem statement. So we will start with understanding what is a real problem statement. Why do you need an AI Kubernetes troubleshooting agent and how it can help organizations in real time. Step 2, tooling. So we will understand what are the different tools that we are going to use to build this end-to-end project. Step 3, architecture or the high-level design. In this step, I'll walk you through the different components that are involved in building this project, and I'll also tell you how each component interacts with other. Step 4, end user workflow. So in this step, you'll understand how an end user interacts with this agent application and how the agent application returns the response back to the end user. Step 5, the final step, is the implementation. And you don't have to worry about it. I've created a GitHub repository where I'll share you detailed steps on how to implement the project. So after watching the video, even you will be able to create your AI Kubernetes agent. All the useful links are in the description as well as the pinned comment. So without wasting any time, let's start with creating the project. Let's start with the problem statement. Why do you need an AI Kubernetes troubleshooting agent? Simple. Kubernetes today is widely accepted as a target platform. Whether you're working on traditional software workloads or you're working on AI workloads, ML workloads, Kubernetes is where these workloads are deployed. While Kubernetes is very popular, troubleshooting Kubernetes is a major challenge. It's not that easy as it looks. Let's take an example. Imagine an organization called XYZ. A DevOps engineer within this organization deploys one of their application as a pod onto the Kubernetes cluster. And DevOps engineer shares the information of the pod with the development team. For some time, let's say the development team or one of the developer is able to access the pod, but after a while, there is some issue with the pod. Developer is not able to access the application. Now, in this case, For developer to troubleshoot the issue, developer should have understanding of Kubernetes, understanding of kubectl commands to use, and different issues on Kubernetes. Because the pod might have gone down because of liveness probe issue, readiness probe, crash loop backoff, image not found, or n number of Kubernetes events. Now this is practically not possible. So developer would reach back to DevOps engineer asking to troubleshoot the issue. Now this is a major challenge. DevOps engineers, most of the time, they spend on troubleshooting the Kubernetes issues because it is not a single developer. Multiple developers across different teams would reach out to the DevOps engineers to troubleshoot issues with the pods or Kubernetes clusters. This can be avoided if you build an AI Kubernetes agent. Of course, this cannot be completely avoided, but significant amount of developers' time and organizations' time can be reduced by building an AI Kubernetes agent. How would this work? Very simple. A developer or a cloud engineer would build this platform and make this platform live. Now, a developer would get to the platform, access the user interface of the platform, access the cluster on which they are finding the issue. If they have access to the cluster, they would click on the cluster and or the relevant pod, and on the user interface, that is on the front end, a clear and detailed issue with the pod is displayed on the screen to the developer. Let's say if it is a trivial issue, maybe the memory issue with the pod or the CPU throttling issue or image issue, developers can fix the issue by themselves. Or if the issue is complex that developers cannot fix it, they at least have more context. Now with the complete context, they can reach out to the DevOps engineering team. So the initial troubleshooting time of DevOps engineers is saved. So this way, AI Kubernetes agent can add significant value for the organization. Okay, now let's move to the next step, the tool set. The best part of the project, tool set is minimalistic and the tools that we're going to use are very, very powerful. For Kubernetes cluster, we will go with kind so that you can spin up a local Kubernetes cluster. For front end, we will go with JavaScript family. For programming language, we will go with Fast API or Python. So using Fast API and kubectl, we will connect to the Kubernetes cluster and we will get the required information. Most importantly, for database, for storage, authorization, LLM integration, and even for deployment of this application, we will go with InSforge. We discussed about InSforge in some of our previous videos, but for people who are new, InSforge is an AI native backend. So you can create a free account with InSforge and you can connect InSforge to your AI coding assistant. It can be anything. You can be using Claude Code, Windsurf, Cursor, Codex. You can just connect that using a click of button. And once it is connected, in plain English, that is using prompt, you can configure your database, storage, authorization, deployment, and even LLM integration in InSforge. So that's why we will go with it. You might have a question, Abhishek, why not go with Postgres? Or maybe why not go with Supabase? Simple, InSforge is designed as an AI native backend, so it makes your life much easier. On top of that, even the tokens that it would take on your coding assistant or on your agent will be significantly less if you go with InSforge. We will see that in the implementation part. So just to repeat, for the toolset, we will use kind for spinning up Kubernetes cluster. For front end, we will go with React. For programming language, we will go with Fast API or Python. And for all the other things like DB, storage, authorization, deployment, and LLM integration, we will go with InSforge. Now that the toolset is clear, let's move to step 3, understand the architecture and high-level design of our Kubernetes troubleshooting agent. You can see there are different components here. Let's try to understand how each component works. As the first thing, user interacts with front end. Within front end, user can connect to different Kubernetes clusters. saying that authorization plays the key role because not every user should get access to the production cluster and troubleshoot the production cluster. And this authorization is taken care by InSforge. We will see in the implementation part how is that done. Now let's say user has access to the cluster. Then the next component is the fast API component. Fast API makes use of kubectl, connects to the Kubernetes cluster and gets the information like the pod information. It can be pod health, it can be the pod status. It also collects logs from different Kubernetes resources. And it also helps with the network information. It inspects the Kubernetes network to see if there is any latency or any issue with the Kubernetes network. Along with that, it also gathers the information of deployment and Kubernetes events. Now, once all of this is done, this information, because this is a lot of information, it is sent to LLM or AI. And again, we will make use of InSforge's open router in this case. Now, if you go with OpenAI, or let's say if you go with Anthropic API key, you can also do that here, but it will be very expensive for you. Open router is multiple times cheaper when compared to OpenAI or Anthropic API keys. Within the InSforge platform, because we are already creating an account and because we are already using it for different purposes, we will also make use of the open router API key that is going to provide. Now, once this information is taken by LLM would analyze the information and summarize the issue for us. Instead of just returning the information to the end user on the front end, we will also store this information on the InSforge database for the investigation history. Let's say you want to see the list of issues that are identified, or you want to see the track of issues in last few days. You need an investigation history. So again, we will store that on the InSforge platform. So this is the high level design or the architecture of our Kubernetes AI agent. You can also find the architecture on the GitHub repository. So if you head to the GitHub repository and look at the README file, you will find high level architecture, the same thing that we discussed on the whiteboard. Along with that, you will also find the end-to-end user workflow. So this is our step 4. Let's understand how the user workflow looks like. When user clicks on investigate cluster, so user would look at the front end. User would click on investigate cluster to understand what's exactly wrong with the cluster. Front end sends the API request. And as we learned, this is where authentication takes place. Authentication is performed, and once the authentication and authorization is performed, request is sent to the investigation layer, which is Fast API. Fast API performs verification of the pods, it reads the logs, it analyzes the events, inspects the deployment, checks the networking, and once this is done, it sends the information for LLM reasoning. As I told you, we will use Open Router through InSforge API key. On the InSforge platform, you will find Open Router API key. Using that, we will send this entire information to LLM reasoning. LLM would perform the root cause analysis. It would come up with a suggested fix. Instead of just returning that to the end user, we will also save that information within the InSforge platform for investigation history. And also we'll show the end user real-time progress updates. So this is how end-to-end user workflow would look like. Now let's move to the implementation part. We will implement component by component. And for the implementation, I will use Cursor IDE. It's up to you. You can use any AI coding assistant or any coding agent. I'll share the prompts in the GitHub repository. You can literally use the same prompts. So if you just head to the prompts folder, so these are the 5 prompts that I'm going to use. Let me go back to the cursor, open a folder. There you go. We will start with implementation now. There are 2 prerequisites. One, you need a Kubernetes cluster. So let me pull my terminal and create a local Kubernetes cluster. Kind create cluster. Let me just call it troubleshooting cluster or Kubernetes demo cluster. In no time, you will have the cluster created. You just need Docker running on your machine. Then the second prerequisite, we should have InSpot setup. And again, this is also simple. You just need to go to the InSpot platform. You can find the link in the description. Just sign up, create an account with it. I've already created an account. So I'll just click on the dashboard. I have some previous projects. I've used these projects. I've demonstrated on the YouTube channel. You can set up your free account and you can start your first project for free. I'll use one of the projects here. Like I've just created this project and I will set up the cursor integration. So you can literally integrate with any of the coding agent. This is what I was talking about. This is the best part. If you're using InSpot, you can configure your storage, you can configure your database, the model gateway, everything through the cursor IDE or any coding assistant that you use on day-to-day basis. You don't have to get here. You don't have to manually configure anything. So I'm using cursor. I'll just click on install. Either I can do through the CLI. I can just provide this prompt or I can just use the MCP install to cursor, paste prompt to cursor. Let me do this. Okay. Open the link. It opened cursor for me. I'll click on install. And if you notice here, it says 17 tools are enabled. So the InSpot MCP server is configured and it has these 17 tools which can help us configure the InSpot platform through cursor IDE. That's all. This is what you have to do. And just to verify if everything is good, you can paste the prompt. So this is the prompt. This is just for verification. I'll just paste it here, change to the agent mode. I'll go with auto just for efficiency. I'm using InSpot as my backend platform. Call InSpot MCP fetch documentation tool to learn about InSpot instructions. This is just to verify if your InSpot is configured well. Or let me just switch to one of the models. I'll go with Composer 2.5. Nice. So run fetch docs in InSpot. Let me allow list of MCP tools. We have the required information. That means the configuration is done. We have set up Kubernetes cluster. We have configured InSpot. So we are all set to build our Kubernetes troubleshooting agent. So let's go to the prompts folder on the GitHub repository. It will take a lot of time to write these prompts. That's why I save them in the GitHub repo. So this is the first one, project setup prompt. What is this going to do? This is going to set up the folder structure for us. Because this is going to be a decent application. The size of the application is going to be decent. So instead of having everything in a single file, we will create a folder structure. So the project is also modular. So this is the prompt. Let me quickly go through this for you. What we are saying cursor, we are building AI Kubernetes troubleshooting agent. This is the architecture. This is the example flow. The goal of the project is to create using fast API backend. We are asking it to use Next.js frontend, or you can go with React as well. The Docker setup, environment variables, and this is the tech stack to use. And when it comes to the project structure, this is the one that I asked to use it. Now it's up to you. If you want to go with a different project structure, you can also go with it. Just head to the repo, modify the prompt. So let me copy this entire thing. I'll open this in the raw folder, copy this, get back to cursor and paste it here. Nice. It is setting up the required files and folders for us. Probably this is going to take 2 to 3 minutes. So the execution is complete. It just took like close to 2 minutes. The folder structure is created. Now we have the backend folder. We have the front-end folder and we have a basic Docker Compose file to run the application along with the agent locally. Right now, it just created basic front-end. In the dark theme mode, it also has very minimalistic options. Let's go ahead and see. If I open localhost 3000, okay, so this is the one that we have at the moment. It has also taken care of CORS. So good first step. Now let's go to the second one. So this is the prompt to Kubernetes investigation engine. Again, we are providing cursor with the information. If you observe carefully, in every prompt, I have provided the user workflow so that cursor is very clear with what exactly we are going to build. And this is going to work with any AI agent that you are going to use. The goal, this layer should behave like junior DevOps engineer, collecting evidence from before the AI reasoning starts. Important, we are not still implementing the AI reasoning. That will be implemented in the third component, the AI reasoning part. We are only collecting Kubernetes troubleshooting data. And I've also provided what kind of data that it has to collect. And individually, I've provided it information like the kubectl executor, what is pod inspector going to do, what is logs collector going to do, events analyzer. As I told you, if I type this entire prompt, it is going to take a lot of time. So that's why I've created this and put this in the GitHub repo. Now let's also copy this. I'll open this in the raw format, Control A, and paste it on the cursor. There you go. So it created bunch of containers for the Kubernetes agent. It was able to figure out kubectl as well, and it is handling errors around the kubectl. Like when kubectl tries to fetch the information, there can be some latency or there can be some retry related issues. It's also handling those issues at this point. Looks like it's done. These are the new backend modules that it added. So if you go to the backend, now we have within the backend Kubernetes, you can find deployment inspector.py, you can find event inspector.py, Kubernetes executor, logs collector. So using fast API, it is getting the information from the cluster. And for that, it is using kubectl executor. As expected, everything looks good. Even in the output summary, it provided, this is the information that it is collecting. So it is collecting crash loop back off, image pull off, image pullback of pending, error, OM killed, most common error information from the pods. It is also connecting different logs from the cluster. When it comes to events, it is looking for these events, deployment, and also network, like the missing endpoints, selector mismatch, and DNS issue. The good thing is that in case we want to add more information, let's say in pods, I want to gather information for liveness probes and rubbiness probes. It's just modifying the prompt. I can add one more instruction and tell cursor also monitor the liveness probe and readiness probe. And our agent will start doing that as well. Cool. So we are done with the step 2. Now we also have the fast API backend. Now let's go to step 3. So we will go back to our GitHub repo. Component 3, add AI reasoning engine prompt. If you remember, we are doing everything according to the architecture. Step 1, step 2, step 3, we are going with the flow. So the prompt 3, we will add the AI reasoning. This is the prompt. The Kubernetes investigation layer is complete. We are done with this. We can now complete Kubernetes troubleshooting evidence. Example, these are the components. This is the architecture. Again, I am providing the agent with the required architecture. What is the goal? We want to make the system intelligent. Previously, in the second prompt, I told it the goal is to behave like a junior DevOps engineer, collect information from the cluster. Here, in the goal section, I'm saying act as a senior Kubernetes SRE and perform investigation. I mean the AI investigation. It should understand Kubernetes failures, correlate the logs, events, deployment state, find the root cause, suggest the fixes, and generate confidence score. Why are we generating this confidence score? Because this is the platform that we are building. We are making use of AI. So we can also tell developers AI is only 60% confident about the issue, or AI is 100% confident about the issue. Perfect. So let's go back, click on raw, copy this entire thing and paste it on the terminal. Now this will implement the AI layer as well for us. And in the prompt, I've provided the instruction very clear. Go with open router via insforge key. But Abhishek, where will you get this open router via InSforge key? If you go back to the platform, there is an option for model gateway. If you head to this section, start using the model gateway active open router key. So I'll just copy this and I will put this in the .env file. Let's say agent is not able to use this open router key, which is very unlikely. Open router is very popular, but InSforge also provides us with the example. So this is the Python example or the fast API example, how you can use the open router API key. It's very similar to OpenAI API key. So any agent will be able to do it. I've already pasted this in the .env file. So execution will go flawless. Now let's go back to our IDE. Even our step 3 is complete. Of course, we cannot visualize the AI investigation at this point because we did not integrate all the components. That is something that we are going to do in the last step. But at least we reached to this point at this moment. We built the front end, we built the fast API backend. Fast API backend is performing the Kubernetes investigation. It sends this information to AI agent. AI agent using large language model, that is the open router, it is going to perform the diagnosis for us. So we are good till this moment. What are the pieces that are left? The critical piece, if we go back to our architecture, are InSforge for storing the investigation history and authorization, also showing the real-time status. These things are pending. This is going to be our fourth component that we're going to build. Again, if you go back to the GitHub repository, prompt for InSforge backend prompt. The goal of this prompt or the action that we are asking agent to execute, create minimal dashboard, implement authentication using InSforge, build real-time investigation progress, show the investigation history, maintain it, and establish front-end and back-end integration. When it comes to authentication, add authentication using InSforge. I'm providing the requirement. I need login support. I'm looking for protected dashboard, user session handling. In the investigation dashboard, I'm looking for AI Kubernetes Agent investigation, where user should see an option for clicking on the investigate cluster. And in the investigation process, user should see the real-time progress, checking pods, checking logs, analyzing the event. What is the action that is taking place at the moment? And also show the root cause on the user interface. So let me go to the raw mode, copy this entire prompt and paste it on the IDE. This is not going to take a lot of time because our MCP is configured, InSforge MCP. Just for example, you can see here, it is creating a table within the InSforge DB. I'm not providing query to create the table. It's using MCP. Using MCP, it gets the information from InSforge documentation and it creates a query and creates the table within the database. So that's the reason why the implementation becomes fast. As a man in middle, if you're providing the queries that are required, then you have to search for the queries or you have to ask AI for the queries. And every time you have to verify if the relevant information is created within the database. Same is with storage. Same is with authentication and authorization as well. Sounds cool, right? Yes. And also if you see here, in the prompt we asked to integrate front end and back end. During the integration, looks like it wanted to download a template. Now it's not asking us to download the template and provide the template information. Instead, it is just asking us to allow the required MCP server and it has downloaded the template. See, template is downloaded successfully. If you're going with Postgres or any other alternative, you have to manually configure most of these things. So finally, our prompt 4 is also complete. The front-end dashboard plus API integration. Prompt 4 is completed. Here is what we have till now. Sign in InSforge. Okay, so we have authentication part set up. Then user can get to see the dashboard. Click on the investigate cluster. Look at the real-time progress, the information, investigation information, what is the progress and summary. history saved and listed. But for this, you should see the database and tables created. Let's see on the dashboard. Cool. So we have two tables created. If we go to database, one is the investigation process table and one is the investigations table. In this table, we haven't run any investigation till now, but once we run investigations, this will have the investigation history and this will show us the progress of the investigation. This information is fetched from here and shown to the user on the front end. And then it also set up slash sign in on the front end. Okay. So the authentication part is also set up. Slash sign in API helps with login, helps with registration, a 6-digit email verification as well. And it will also show the dashboard on the main user interface. So InSforge has also implemented this for us. Cool. Let's start the backend using Docker Compose and see if everything that we're looking for is in place. So Docker Compose, I'll switch to the folder. In my case, I'm in the downloads folder. The project is here, followed by Kubernetes AI Kubernetes Agent. Okay, let me run Docker Compose -- build. It has started the containers. Application startup complete. Let's go back to localhost 3000. Previously, when we looked at the localhost 3000, we directly saw the option for investigate cluster because the authentication was not set up. Now let's see. On localhost 3000, I see an option for sign in. Cool. I don't have an account. Let me just click on sign up and create an account. I'll use one of my email addresses. Okay. And let me also set up a password real quick. Click on the sign up. It says network request failed, network error when attempting to fetch resource. Probably there is something missing or there is some issue with front end and back end integration. Not a problem. Let's provide the same error. Looks like it found the issue. So it says identifying the issue. The Docker front end build omits the InSforge environment variables and it is also working towards fixing this issue for us. Great. So now the issue is fixed. Let's try it again. I'll go back, click on sign up, refresh. Cool. So this time it has created an account for us, but for verification, it sent a 6-digit email code. I got that on my mobile. I'll just enter this here, verify. My bad. There is a typo, 492310. Let's verify. So this is my email ID. Now only authorized users can access the platform. If you implement this within your organization, you can only allow your organizational email IDs, or you can only allow certain email IDs, certain users, certain teams. It's up to you. You just have to add an entry in the database. No previous investigations makes sense because we haven't investigated anything yet. Once we run some investigations, then it will fetch the information. Basically, how the previous investigation history is fetched. So the backend would get that information from database. It would go to investigations table. Here, the investigation information would be saved. So the ID, user ID, I mean, the user who triggered the investigation, session ID, what is the root cause, in which namespace, and what is the status. All this information will be pulled from here and displayed to the user on the front end. Nice. Now we are only left with one thing, that is the end-to-end integration. Right now you see an option for investigate cluster, but ideally I should see different Kubernetes clusters, various Kubernetes clusters, part of your organization. In my case, various Kubernetes clusters running on my machine, and I should be able to click on the relevant Kubernetes cluster and perform the integration. Even at this moment, the Kubernetes cluster is not connected to the platform. So for that, we will execute our final prompt. The end-to-end investigation prompt or end-to-end integration prompt. What is this going to do? Goal, integrate everything end-to-end. Test real Kubernetes failures. Improve the reliability. And I've also provided the end-to-end user workflow here. I've provided how to get the Kubernetes cluster information. So I'm telling it to get the Kubernetes clusters from my local machine. If you're doing it within your organization, you can say get the information from a kubeconfig or from the OAuth, SSO, whatever is the feasible option for you. Let me go to the raw mode, copy this entire prompt and paste it on the IDE. Now this will set up the complete integration for us. This might take another 2 to 3 minutes. We can track the things in the meanwhile. So a new feature is created, the cluster selection feature. From kubeconfig, it will fetch the list of clusters on my local machine. In your case, as I told you, you can go with a different option if you're doing this within your organization. And then it also improved the reliability of the front end as well as back end. Cool, it is all done. Now I just have to run Docker Compose up -- build. So all the components are rebuilt. Let's go back to the terminal. First, I'll run Docker Compose down so that the existing containers are destroyed. Now I'll run Docker Compose up -- build. Great. So application startup is complete. The AI Kubernetes agent, the troubleshooting agent is running all good. Let's see. I'll go to the browser. I'll access localhost 3000 again. There we go. So now this is the authenticated user. These are the list of clusters. I can select a cluster and click on investigate the cluster. But I really don't like the user interface that much. Let's ask the cursor to enhance the user interface. The backend part looks good. The database related configuration also looks good, but only the user interface can be much better. It should not take much time. In less than a minute, we should have this user interface beautified. I'll just go back to the IDE and I'll provide it with a prompt. Beautify the user interface. Do not change any features because the features are all good. Now the execution is complete. UI is updated with cohesive visual design. No features or behavior were changed. These are the changes to the UI. Let's see by rebuilding the front end. This time we just have to rebuild the front end. So I'll just go back or let me restart everything. It wouldn't take more than 30 seconds. Restart is complete. Application startup is also complete. Let's try again. So I'll try to access localhost 3000 one more time. This time I hope user interface would be better as expected. So now the signed in user gets a display picture, better user experience. Also the clusters are in the tiles form. I can easily navigate through the cluster. I can read the names of the clusters. I can select the cluster and click on investigate. Also, this is the place where previous investigations are shown. So definitely much better than the previous user experience. Let me click on the demo Kubernetes cluster, the one that we created at the beginning of the video, and click on investigate cluster. Right now, I haven't deployed anything to it. Only the default resources are in it. So I hope there will not be any issues with the cluster. Let's see. Investigating Kubernetes cluster, checking pods. There you go. So it is checking the pods, it is reading the logs, it is analyzing the events, inspecting the deployments, checking the networking, AI reasoning. So this will take time because all of this information should be sent through Open Router to the relevant large language model. Open Router picks up the best one and it also found the root cause. Fine, it says there is one issue, root cause, core DNS pods are failing because of readiness probes. This is expected because we are using kind cluster, but other than that, there is no other issue on the cluster. This is totally fine. We can ignore this. But now we are confident that our AI Kubernetes troubleshooting agent is working as expected. If we go to the InSforge backend and go back to the dashboard, now on the project, I'll go to the databases. So in the databases section, I'll pick up the table. So these are databases, investigations. So this is the past investigation. You can clearly see core DNS pods are failing, and this will be reflected even in the investigation history. Let me refresh. Okay. Now if I scroll down, recent investigations. If you want, you can move this to a different HTML page as well. That's not a big deal. You can either have it here or just move to a different page or different view, anything that you like. Now let's take the next step. Let's deploy an Nginx pod onto the Kubernetes cluster. And the Nginx pod we will deploy in a way it goes to the crash loop backup state. And let's see if our Kubernetes troubleshooting agent will it identify the Nginx crash loop backup issue. Right? Let's do that. So I'll go to the Kubernetes cluster. I'll deploy Nginx pod using kubectl run Nginx crash. This is the deployment name. The image is Nginx latest, but in the command, I'm just passing exit1 so that Nginx container within the pod goes to the crash loop backup state. Perfect. Let's see. Okay, Nginx crash is created. Let's verify from here. kubectl get pods. Container is creating. It is yet to create the container, and then it has to run this command exit1. Only then the container goes down and pod goes into crash loop backup. Let's see. Okay, it moved to error status. In a while, it will also go to the crash loop backup. Perfect. Let's go here. Let's refresh this. Now let's run investigation on the cluster. Now this is going to be interesting. This is where we are going to test our Kubernetes troubleshooting agent. It has checked the pods. Probably by this time, it should have understood the Nginx related issue. It sent the information for AI reasoning through Open Router. Root cause found. There you go. Nginx crash. Pod failed due to the node being rebooted, causing a loss of state and subsequent pod failures. kubectl command, run this command for deleting the pod. And you can see here it says 75%. So AI is not 100% confident about it. What AI did here, it explained the issue for us. So this is the root cause. This is the explanation why Nginx pod is in the crash loop backup state or in the error state. Suggested fix, investigate the node's reboot cause, and then ensure the node is stable. Obviously, this is not going to fix the issue for us. That's why 75% is only the success rate, or 75% is the confidence. When AI is 100% confident about the issue, then you would see 100% rate here. It depends on a lot of things. Now, Open Router might have used a specific model because we haven't hard coded the model. Let's say you go with the Claude Opus 4.7, which is a very high reasoning model. You can hard code that within your application, the agent application. Then you might see the success rate as 70%, 80%, 90%. It depends on that. Anyways, what we are trying to build is built successfully. Now let's also try it one more time. This time, let's look at the end-to-end workflow. Right from sign up, we will create an issue on the cluster. Then using this agent application that we built, let's see if the workflow is working fine. So this is our AI Kubernetes troubleshooting agent. We already created an account. So let me quickly sign into it. So this is a signed in user and it has a list of clusters. These are all the clusters that I have access to, almost 14 Kubernetes clusters. I'll select one of the cluster and click on the investigate cluster. It will show the current status of the cluster and any issues on the cluster. Now intentionally, let's create an issue on this cluster. So I'll go to my terminal. I'll deploy an Nginx pod. This is an Nginx pod. that has an invalid image, kubectl run nginx image pull back off. This tag does not exist. So basically, when you run this, a pod will be created and the status of pod would be image pull back off. There you see error image pull and the next status would be image pull back off. Perfect. Now we should see this. Let's say there is a developer finding it difficult to understand what went wrong with the cluster or what went wrong with the pod. They can come here, click on it and click on investigate the cluster. If they have access to the cluster right now, this is using my kubeconfig file. So I have access to it. What is it doing? It is investigating, checking the pods, reading the logs, analyzing the events, inspecting the deployments, checking the networking, giving this entire information to AI. Basically, we are using open router here and root cause found. You can see it performed the root cause. What does it say? The pod nginx image pull backoff is in pending state due to an image pull error on non-existing image tag. It exactly explained you the issue. This is the image that you're using and this image is invalid image. Just use the valid image, something like nginx latest. It also gave the kubectl command. This is the confidence score. AI is confident that the command is 80% correct or the investigation is 80% correct. There is a reason for it. Why is it not 100%? Because there is a possibility you might not want to use this image. Maybe your organization wants to use a different image. And it also says, how do you prevent these issues in the future? Probably use the CI/CD checks. On top of that, we also have the recent investigations. Till now, we did 3 different investigations and all of the information is stored here. Where are we getting this from? We are getting this from the InSports database that we configured. And this is also automatically configured. We have investigations table and we have investigation progress. All the previous investigations progress is here, the different steps that were performed. And these are the different investigations. First issue was because of core DNS. Second issue was because of nginx crash, the crash loop backoff. And the recent one is because of nginx image pull backoff. The same information is shown here. If you want, as I told you, you can make a cool addition. Probably you can move this diagnosis information, the recent investigations information to different pages or different views on the platform. This is exactly according to the user workflow that we have in the README file. In the README file, this is the workflow that we wanted, and we got the same end-to-end workflow. Perfect. So I hope you found the video insightful. So this is how you build an AI Kubernetes agent using Python and InSports. Once again, all the useful links are in the description as well as the pinned comment. You can also take a look at the GitHub repository. Let's say you want to understand more about architecture or the prompts that are used in the video. If you have any questions, do let me know in the comment section. I'm more than happy to help. See you all in the next video. Take care.